My name's Nick, I'm a maths tutor, and today we're going to go through paper 3H from June 2019. Let's give it a go. Okay, so the first question is a Venn diagram. We have to complete the Venn diagram and represent the information. So we're told that A is 1, 5, 6, 8, 9 and B is 2, 6, 9. We can see that 6 and 9 are in common for both A and B, so they go in the intersection in the middle. Then we can distribute 1, 5 and 8 within A and 2 within B, and then that leaves us with 3, 4 and 7, which sit outside of A or B. Next we have to do part B, which is find the probability that the number is in the set A intersect B. This is the two numbers 6 and 9, so out of the 9 numbers that we have, 2 are in the intersection, which means that the probability is 2/9. Katie invests £200,000 in a savings account for 4 years. The account pays compound interest at a rate of 1.5% per annum. Calculate the total amount of interest Katie will get at the end of 4 years. So we do 200,000 multiplied by 1.015 to the power of 4. This will give us the amount we'll have after 4 years of compound interest. That's why we do it to the power of 4. This gives us 212,272.71. So then we take this amount and subtract the original amount of 200,000 to find the interest Katie's going to get at the end of the 4 years. This leaves us with 12,272.71 as our final answer. The table shows information about the heights of 80 plants. Find the class interval that contains the median. So we have 80 plants, we need to find where the 40th plant lies because that will be the median, okay? We can calculate our cumulative frequency on the right hand side of the table. So we go 7, 20, 34, 46. So from this we know that in the class interval of 40 to 50, this is where the 40th plant lies, which is the median. So, part B, on the grid, draw a frequency polygon for the information in the table. So what we do is we find the middle value for each of the class intervals, because this is like our average. So we've got 10 to 20 is going to be 15, then we get 25, 35, 45, 55, 65, and then we just plot these values against the frequency. So we're going to have 15, 7, 25 and 13, 35 and 14, 45 and 12, 55 and 16, and then 65 and 18. So, using straight lines, we join up all of the points and we end up with our frequency polygon as requested in the question. Sean has drawn a time series graph to show the numbers in thousands of visitors to a fun park. Write down 2 things that are wrong or could be misleading with this graph. So, there's always going to be more than 2 things available for these kinds of questions, so just see what comes most obviously to you. The 2 that I came up with were the points should be joined together with straight lines and the x-axis doesn't clearly present the information. The diagram shows a hexagon. The hexagon has one line of symmetry. FA equals BC, EF equals CD, angle ABC equals 117 degrees, angle BCD is 2 times angle CDE, work out the size of angle AFE, you must show all your working. So we can mark out our diagram where we have EDC as theta and DCB as 2 theta because we're told that the angles are double the size at this point. We also know that because of the line of symmetry, it means that the angle BAF will be 117 degrees, and AFB was going to be BCD, and FED is going to equal CDE, okay? So I've marked out the diagram, I've drawn my line of symmetry, and now we can calculate the angles within a hexagon. The way I did this is I calculated the exterior angle of a regular hexagon by doing 360 divided by the number of sides, which is 6. That gave me 60. Then to find the interior angle, I did 180 minus 60 to get 120. And then I did 120 times 6, because there's 6 interior angles in a hexagon, to make 720. And if there's 720 degrees in a regular hexagon, that is going to be true of all hexagons. So now that I've got my angles added up within a hexagon, I can use algebra to figure out the rest. So 117 times 2 plus 2 theta times 2 plus theta times 2 equals 720. I can then rearrange for theta, so I end up with 6 theta equals 486 degrees. Now that we have 6 theta equals 486 degrees, I can calculate 2 theta, because this is our angle AFE. That is going to give us 162 degrees as our final answer. Jeremy has to cover 3 tanks completely with paint. Each tank is in the shape of a cylinder with a top and a bottom. The tank has a diameter of 1.6 metres and a height of 1.8 metres. Jeremy has 7 tins of paint. Each tin of paint covers 5 metres squared. Has Jeremy got enough paint to cover completely the 3 tanks? You must show how you get your answer. So the first thing is the diameter is what we're given, and we need the radius, as you'll see in a minute. So 1.6 divided by 2 gives us 0.8. the top and the bottom of the cylinder will result in 2 times pi r squared, because that's the area of a circle, and then we have the top and bottom, so there's 2 of them. So we get 2 times pi r squared, which is 2 times pi times 0.8 squared. That gives us 4.02 meters squared. Next, we need to find the curved surface area of a cylinder. So we do 2 pi rl, because 2 pi r is the perimeter of a circle, and times l gives us that curved surface area. So we do 2 times pi times 0.8 times 1.8, and that gives us 9.05 meters squared. Now that we have the top and bottom and the curved surface area, we just add this all together to find the surface area of one tank. So 4.02 plus 9.05 is 13.07 meters squared for one tank. For 3 tanks, this is going to be 3 times 13.07, which gives us 39.21 meters squared. The total amount of paint we have is 7 tins, and each tin covers 5 meters squared, so 5 times 7 is 35 meters squared, and that's the total amount of paint that we have available. That means that Jeremy does not have enough paint, as he needs 39.21 meters squared to be covered, and he only has 35 meters squared available. Work out the square root of 2.5 times sine 43 degrees over 8.2 squared minus 50.5. Give your answer correct to 3 significant figures. So this question's only 2 marks, and of course you could plug it in your calculator, but we need to show our working. So what I did is I've worked out the denominator first, and that gave me 16.74, and then I plugged the rest into my calculator, and that gave me 0.3191419.855, and then you need that to 3 significant figures, so you just round that to 0.319. Next, we have question 8. ABC is a right-angled triangle. Here is Sarah's method to find the length of BC. So we've got her working here. What mistake has Sarah made in her method? The first line is incorrect. AB squared plus BC squared equals AC squared. This is Pythagoras' theorem. That means that BC squared equals AC squared minus AB squared. You could also say that AC is the hypotenuse, not BC. So, Roy is going to enlarge triangle PQR with centre C and scale factor 1.5. He draws triangle XYZ. Explain why Roy's diagram is not correct. So, we've got 2 options here. It's either going to be the centre of enlargement or the scale factor, okay? We know that the centre of enlargement is C, so that's not the issue. It has to do with the scale factor. So, we need to work out the scale factor, and this is 2.5, which means that Roy has used a scale factor of 2.5, not 1.5, meaning the triangle XYZ is too big. A company has to make a large number of boxes. A company has 6 machines. All the machines work at the same rate. When all the machines are working, they can make all the boxes in 9 days. The table gives the number of machines working each day. Work out the total number of days taken to make all the boxes. We're told in the question that 6 machines working for 9 days can make all the boxes. So we can do 6 times 9 equals 54, and this will provide us the number of machine days needed to produce all of the boxes. If we add 3 plus 4 plus 5, that gives us 12, which is the number of machine days after 3 days of work, as we're given in the question with the table. 54 minus 12 equals 42, which is the number of machine days left in order to produce the total amount of boxes. 42 divided by 6 is 7, and that is the number of extra days needed in order to produce all of the boxes. So we add 3, the number of days at the beginning, plus the 7 extra that we need, which gives us 10 overall as the number of days needed to make all of the boxes. Marie invests £8,000 in an account for 1 year. At the end of the year, interest is added to her account. We're not told how much. Marie pays tax on this interest at a rate of 20%. She pays £28.80 in tax. Work out the percentage interest rate for the account. So we can use x to represent the amount of interest. So 8,000 times x is going to be the amount we have in the account after 1 year before tax. Then we do 8,000x times 0.2 to give us 28.8, because that is going to be the amount of tax that she's paid out from her account. So we can rearrange our equation to solve for x, and this will give us 0.018. As a percentage, this is 1.8%, which means that Marie has received 1.8% interest on her account. In May 2019, the distance between Earth and Mars was 3.9 times 10 to the 7 kilometres. In May 2019, a signal was sent from Earth to Mars. Assuming that the signal sent from Earth to Mars travelled at a speed of 3 times 10 to the 5 kilometres per second, how long did the signal take to get to Mars? So, speed equals distance over time, and this implies that time equals distance over speed. Using this, we can solve for the time taken to get to Mars. So we've got 3.9 times 10 to the 7 kilometres, which is the distance between Earth and Mars, divided by 3 times 10 to the 5 kilometres per second, leaves us with 130 seconds, as the time taken. The speed of the signal sent from Earth to Mars in May 2019 was actually less than 3 times 10 to the 5 kilometers per second. How will this affect your answer to part A? So because the speed is slower, the time taken will be longer, okay? So that's what I've given in my answer. Patrick has to work out the exact value of 64 to the power of a quarter. Patrick says a quarter of 64 is 16, so 64 to the power of a quarter equals 16. Explain what is wrong with what Patrick says. My answer is 64 to the power of a quarter does not equal a quarter of 64. 64 to the power of a quarter is the square root of 8, not 16. The density of ethanol is 1.09 grams per centimetre cubed. The density of propylene is 0.97 grams per centimetre cubed. 60 litres of ethanol are mixed with 128 litres of propylene to make 188 litres of antifreeze. Work out the density of the antifreeze, give your answer correct to 2 decimal places. So we know density equals mass over volume, and this implies that density times volume equals mass. 1 litre is 1,000 millilitres, which is the same as 1,000 centimetres cubed. That means the mass of ethanol is going to be 1.09, the density, times the volume in centimetres cubed to give us the number of grams, which is 65,400 grams. The mass of propylene is going to be 0.97 times 128,000, i.e. the volume in centimetres cubed, to give us 124,160 grams. We need to add the mass of the ethanol and the propylene together to give us the mass of the antifreeze, which is 189,560 grams. To calculate the density, we then need to do the mass of the antifreeze divided by the volume of the antifreeze. That's 189,560 divided by 188,000. This gives us 1.00829, which rounds to 1.01 grams per centimetres cubed. The diagram shows a rectangle ABDE and 2 congruent triangles AFE and BCD. The area of rectangle ABDE equals the area of triangle AFE plus the area of triangle BCD. AB to AE is the same as 1 to 3. Work out the length of AE. So, first things first, FM is going to be equal to 24 sine 30, which gives us 12 centimetres. Okay, so now we basically have the height of that triangle on the left-hand side. The area of AFE is going to be a half times AE times 12. Okay, so you can think of this as half base times height. A is the base and 12 is the height FM, which we just calculated. This gives us 6 AE. The area of ABDE is equal to the area of AFE plus the area of BCD. We're told that in the question. AB times AE is going to be the area of our rectangle, and we know that the area of one of our triangles is 6AE, so that means that AB times AE equals 6AE plus 6AE. AB times AE is therefore equal to 12AE. AB equals 12 because we divide AE from both sides. Then, using the ratio of AB to AE is 1 to 3, we can multiply AB times 3 to get AE. 12 times 3 is 36, so we get 36 centimetres as our answer. The graph of the curve C with equation y equals fx is transformed to give the graph of the curve S with equation y equals f minus x minus 3. The point on C with coordinates 7, 2 is mapped to the point Q on S. Find the coordinates of Q. So what I've done here is I've drawn out each of the diagrams to give me a sense of the transformations taking place. Fx, when turned to f minus x, is a reflection in the y-axis. Then that gives us minus 7, 2 for our point. Then when we do y equals f of minus x minus 3, we translate 3 down from where we were. So that means we get minus 7 minus 1 as our point, and that gives us our answer. Here are the first 6 terms of a quadratic sequence: minus 1, 5, 15, 29, 47 and 69. Find an expression in terms of n for the nth term of the sequence. So here it is key that you work out the difference of the terms. So that's how you get the plus 4, plus 4, plus 4, plus 4, and this gives you a mark, and that is essential in your answer. Then you can start writing out all of the terms of your sequence and try and figure out the quadratic that's being used. N squared is 1, 4, 9, 16, 25, 36, because that's just n squared for each term. Then 2n squared is going to double all of those, so we get 2, 8, 18, 32, 50, 72, and then we can start thinking about how we get from 2n squared to our term that we're given in the question. In this case it's minus 3, so 2n squared minus 3 gives you minus 1, 5, 15, 29, 47, 69, so therefore our answer is 2n squared minus 3. Here are 4 graphs. The graphs represent 4 different types of function f. Match each description of the function in the table to the letter of its graph. Fx is inversely proportional to x. So this is b, because as you can see, when we have very small values of positive x, we get very large values for y, and when we have very small values of negative x, we get very large negative values of y, and as x increases in the positive direction, we get a smaller y value, and as x increases in the negative direction, we get small values of y, which suggests that it is inversely proportional to x. Then fx is a trigonometrical function. So this is a. We can see this is sine x. If you're not sure, just give that a double check and then we can move on. Fx is an exponential function. This is a graph of the type y equals pq to the power of x. And as we can see, as x gets larger, y gets exponentially larger, which is why it's graph D. Then we're left with c, which is fx is directly proportional to the square root of x. Show that 2x plus 1 times x plus 3 times 3x plus 7 can be written in the form ax cubed plus bx squared plus cx plus d, where a, b, c and d are integers. So the first thing I did is I wrote out 2x plus 1 times x plus 3 in the grid method, which gave me 2x squared plus x plus 6x plus 3. This simplifies to 2x squared plus 7x plus 3. Then, using the grid method again, I used 2x squared plus 7x plus 3 and multiplied that by 3x plus 7, the remaining bracket we have to expand. This gave me 6x cubed plus 21x squared plus 14x squared plus 9x plus 49x plus 21, and that simplifies to 6x cubed plus 35x squared plus 58x plus 21. Finally, we have to solve 1 minus x squared is less than 9 over 25. The first thing we need to do is square root both sides. But remember, we can have a positive square root and a negative square root. The positive square root is going to be larger than 1 minus x, and the negative square root is going to be smaller than 1 minus x. Following on from this, we find our square roots, so we get minus 3/5 on the left-hand side and positive 3/5 on the right-hand side. We can then subtract 1 from both sides, so we get minus 8/5 on the left-hand side and minus 2/5 on the right-hand side, and then we can multiply everything by minus 1 to get rid of our negative signs. Remember, this flips our greater than signs to less than signs, and vice versa, so we end up with 8/5 on the left-hand side and 2/5 on the right-hand side, which gives you the final answer of 2/5 is smaller than x, which is smaller than 8/5, so we know that x lies between those two bounds. D equals u squared over 2a. U equals 26.2, correct to 3 significant figures. A equals 4.3, correct to 2 significant figures. Calculate the upper bound for the value of D. Give your answer correct to 6 significant figures. You must show all your working. The upper bound of D, which is what we're looking for, requires the lower bound of A, because it's the denominator of the equation, and the upper bound of U, as it's the numerator on the equation. The lower bound of A is 4.25 because we've got it correct to 2 significant figures, and the upper bound of U is 26.25 as we've got it correct to 3 significant figures. The upper bound of D is therefore 26.25 squared over 2 times 4.25, which gives us 81.0661767. Then we need the answer to 6 significant figures, so we round this to 81.0662. The lower bound for the value of D is 78.6003, correct to 6 significant figures. By considering bounds, write down the value of D to a suitable degree of accuracy. You must give a reason for your answer. I said D is 80 to 2 significant figures, as both the lower bound and the upper bound round to 80. Solve algebraically the simultaneous equations. So x minus 2y times x plus 2y equals 9. Here I've completed the square to get my equation. X equals 7 minus 4y over 3 because I've rearranged the second equation. So then I substituted my value for x into the original equation that I found by completing the square. So I get 7 minus 4y over 3 minus 2y multiplied by 7 minus 4y over 3 plus 2y equals 9. We can then simplify all of this and we end up with 7 minus 10y times 7 plus 2y equals 81. Then we can expand our brackets, so we have 7 minus 10y times 7 plus 2y, and this leaves us with minus 20y squared minus 56y plus 49 equals 81. Then we can subtract 81 from both sides, and we end up with minus 20y squared minus 56y minus 32 equals 0. Then we can simplify this a little bit by dividing by minus 4, and we get 5y squared plus 14y plus 8 equals 0. And now we have a quadratic with y. So now that we have a quadratic with y, we can simplify to make 5y plus 4 times y plus 2 equals 0. This gives us our roots of y equals minus 4/5 or minus 2. So now that we have our roots for y, we can substitute in our values of y to find our value of x using x equals 7 minus 4y over 3. This gives us x equals 7 plus 8 over 3, which is 5, and then x equals 7 plus 3.2 over 3, which is 17.5. This gives us our answer of x equals 5 and y equals minus 2, or x equals 17 over 5 when y equals minus 4 over 5. The histogram gives information about the distribution of the weights of some onions grown by a farmer. Onions less than 60 grams in weight are used for pickling. Onions greater than 120 grams in weight are sold at the market. The rest of the onions are sent to a food processing factory. So here we need to work out the area of our bars for the histogram. So 60 is the base times 2 is the height, gives us 120 for the first bar. Then we need to do 90 minus 60 times 5, which gives us 150 for the next bar. 120 minus 90 times 9 equals 270. Then we get 135 minus 120 times 6 is 90. Then we get 180 minus 135 times 2 equals 90. And then we have the area of all of our bars. Then we can see that 120 are used for pickling because these are the ones that are less than 60 grams. In total, 420 are going to be processed because that lies between 60 and 120. Then finally, we can figure out that 180 are sold and that we have 720 onions in total. The proportion of onions used for pickling is going to be 120 over 720, which is 60 over 360. The number that are going to be processed comes down to 210 over 360, and the number that is going to be sold is 90 over 360. We've left everything in terms of 360 because this adds up to our pie chart, which we're going to use. So we can see that 210 is the angle used for the number of onions being sent to the food processing factory, which means that x is 210 degrees. The diagram shows a circle centre O. AB is the tangent to the circle at the point A. Angle OBA equals 30 degrees. Point B has coordinates 16, 0. Point P has coordinates 3PP. Find the value of P. Give your answer correct to one decimal place and you must show all of your working. So the first thing I did is I marked out the tangent on the diagram using 90 degrees because it's perpendicular, and then had a go at solving for OP. So the first thing I did is I drew out my diagram. So I have OAB here on the left hand side, and you can see that the hypotenuse are going to be 16 because we're told that B is at the point 16, 0, and this makes up our hypotenuse on that triangle. 16 sine 30 is going to equal OA, our opposite side, which is the radius. This equals 8, which is also equal to OP because it's also the radius of the circle. Next, I wrote another triangle down, so I have OPM here on the left-hand side. We know that OP is going to be 8 because that's the radius. So we know OM is going to be 3p because that's the horizontal distance to the coordinates that we have of 3pp, and therefore our height is also going to be p because that's the y-coordinate of our coordinates. So we have 8 squared equals 3p squared plus p squared when we use Pythagoras' theorem. 64 equals 9p squared plus p squared, which is 10p squared. Therefore, 6.4 equals p squared, and p equals the square root of 6.4, which rounds to 2.5 to one decimal place. The diagram shows the positions of 3 towns: Acton A, Barston B, and Chawton C. Barston is 8 kilometres from Acton on a bearing of 037 degrees. Chawton is 9 kilometres from Barston on a bearing of 150 degrees. Find the bearing of Chawton from Acton. Give your answer correct to one decimal place. You must show all your working. So the first thing we do is we draw a line between A and C, because this is our distance from Chawton to Acton. Then, drawing a vertical line from B downwards, we can see that the angle that makes up the straight line of B, going from north to south, is just 30 degrees missing there. Then we know that the 37 degrees is going to be that other angle because we can use alternate angles to find that. So that means our total angle for ABC is going to be 67 degrees. Now we can write out our triangle for the whole thing. So ABC, we're going to have 8 as our value for AB because we're told that already. Our value of BC is 9, which we're told already, and then 67 degrees, which is the angle we've just calculated for ABC. Then I'm going to use theta as my angle for BAC, because we need to find the bearing of Chawton from Acton. Using the cosine rule, we end up with AC squared equals 88.73, and therefore AC is the square root of 88.73, which is 9.42 kilometres. Next up, we need to use the sine rule to calculate our angle theta, which we're then going to use to find our bearing. So, sine theta is equal to 9 times sine 67 over 9.42, and then we can inverse sine both sides, and we end up with theta equals 61.6 degrees. We then add this to our original angle of 37 degrees, which is the angle of Barston from Acton, and then we end up with 98.6 degrees as our final answer. But remember, this is a bearing, so we need to write it with 3 digits at the beginning, 098.6, which gives us our final answer. And there we have it. June 2019, paper 3H is done. If you want to see any videos from November 2019, just click these videos here. And if you're interested in signing up for online group maths tutoring classes run by me, make sure to sign up in the link below. It will be starting on the 24th of June, so I look forward to seeing you guys there. And remember to hit those videos, yeah?